Hi everyone, in today's lesson I'm going to show you how to write the equation of a hyperbola given some of its parts. Just to review, a horizontal hyperbola is when x squared come first, a vertical hyperbola is when y squared comes first, and a and b are always in that same order. A comes first and then b comes second. So in order to write an equation we're going to need three things. We need a center, which I have here. We need an a and a b value, which are here, and we need to know if the hyperbola is horizontal or vertical, so I know what to come first, x squared or y squared. So let's look at a few examples. Okay, example number 1, I have vertices at 3, 0, so I'm just going to draw a quick sketch. So this is a vertex we'll call V1, and negative 3, 0, which we'll call V2. So that being said, we know that the parabola, or excuse me, the hyperbola is going to look something like this. So we know it's horizontal. So since we know it's horizontal, we know that the x squared is going to come first, and then the y squared comes second. And we know that the vertices are equidistant from the center, so the center must be the origin. So it's going to be x squared over y squared, and then minus equals 1. And we know that the a value is the distance to the vertices. So from here to here is a, and from here to here is a. So that means a is equal to 3. So that tells me right now that on the bottom right here is going to be a squared, so 9 will go here. So the only thing left that we need is the b value. And the only other piece of information that I have are my foci. So my foci are 4, 0 and negative 4, 0. So my foci are here and here. And these are c units away from the origin. So I have an a value and I have a c value, which are 4 units away and 3 units away. So I can use the formula c squared equals a squared plus b squared to find my b squared. So if c is 1, 2, 3, 4 units, so I can even write that up here, c is 4, and I want to do c squared, that would be 16. A squared, so 3 squared, is 9, plus b squared. Subtract 9 on both sides. You should get 7 equals b squared. And I don't even need any more because I know in this formula it's b squared, and b squared is in fact 7. So this is my equation of my hyperbola. Okay, let's see if we can try number 2 now. Drawing a sketch again. I have vertices at negative 2, 0, so we'll call this V1, and negative 2, negative 6. So V1 and V2. So right now, just with the vertices, this tells me my hyperbola is going to be vertical. And it's clear that my center is not at the origin. My center is in the middle of these two. So if I'm going down 6, then I really just need to go down 3, and here's my center. Okay, so it looks like my center value is negative 2, negative 3. So we know the distance from the center to either of the two vertices is a. So if I look here, I have 1, 2, 3. So therefore my a value is 3. So far I have an a value, a center, and I know that it opens vertically. Alright, let's see what else I know. I have foci at negative 2, 2. So let's go ahead and graph those. So negative 2, positive 2 is my foci. So foci 1. And negative 2, negative 8 will be my second foci. And we know that the foci are c units from the center. So here and here. So if we count, this is at 3, 4, 5, 6, 7, 8. So from here to here is my c value. So it looks as though my c value is 5. So that tells me here that c is equal to 5. So now I can use the formula c squared equals a squared plus b squared to find my c value, or excuse me, my b value. So c squared is 25, a squared is 9, plus b squared, minus 9 on both sides. I should get b squared equals 16. So the formula is set up this way. The a always goes underneath the a squared, so 3 squared is 9. The b squared, which is 16, always goes under the second. And then the formula is the opposite for the centers. So it's going to be y minus 3 squared and x plus 2 squared. So remember, it should be a plus 2 and a plus 3. And remember, the x plus 2 squared goes with the center value of a negative 2, so it's opposite, and the negative 3 value goes with a positive 3 in the beginning. So this is my equation of my hyperbola. Alright, let's see what we could do on the next page. Okay, so number 3 is that I have foci at negative 3, 5, and 5, 5. And the length of the transverse axis is 6. Now remember, the transverse axis holds the vertices, the center, and the foci. So let's graph what we have so far. So F1, and 1, 2, 3, 5 was here, which is F2. Those are my two foci. So that tells me my vertices are going to be somewhere in here, and my hyperbola is probably going to be horizontal. So far I know that it's a horizontal. We know the center is equidistant from these two. So if this is 5 over and this is 3 over, that's 8. So my center will be here. So I know my center is 1, 5. And we know it's horizontal, so we can go ahead and start. So it's x minus 1 squared minus y minus 5 squared equals 1 over some a and some b. So we need to know what a and b are. So how can we use this that we have the length of the transverse axis to be 6? The transverse axis stops at the two vertices. So if that has to be 6, then that means I'm going to go over 3 and then left 3 to get 6. So watch. Let's count over 3. So here we'll say is V1, and here we'll say is V2. Okay, so my vertices are 3 from the center. So that means A is 3. So my hyperbola will look something like that. So we have A is equal to 3, and we know that the foci, if this is the center, we said that this was 4 and 4, so my C value is 4. So now we just need to find B. So C squared equals A squared plus B squared. So C squared is 16, A squared is 9, plus B squared. So minus 9, which gets 7, is equal to B squared. So that's going to go here, and A squared is 9, and we're done. Alright, number 4 is a little tricky, but I want you to give it a shot for homework. And let's move on to the last example. Is given the equation in general form, can we complete the square to make the equation of the hyperbola? So we're going to group the x terms and the y terms together. Now, it's always going to be in the formula x minus y or y minus x. So the x has to be positive or the y has to be positive. So look, whichever one is positive comes first. So we're going to bring the 4x squared first, minus the 48x, minus the 9y squared, plus the 72y, equals negative 144. Now we're going to take out those leading coefficients, so we're going to take out a 4. And we're going to complete the square. So half of negative 12 is negative 6. Negative 6 squared is 36. Half of 8 is 4. 4 squared is 16. So we're going to multiply 4 and 36, and then 9 and 16, and we'll add it to both sides of the equation. Okay, when you multiply 4 and 36, you get 144. And then when you multiply 9 and 16, you get 144 as well, but it's a negative 9, so it's actually going to be a negative 144. Okay. Alright, so if we add this side, this right-hand side, negative 144 plus 144 cancels to 0, so these cancel out. So let's finish completing the square over here. It's just going to be x minus 6 squared minus 9y plus 4 squared equals negative 144. Now, in order to get this equation equal to 1, we have to divide all the sides by negative 144. Okay, and then when you reduce this fraction here, you should get negative x minus 6 squared over 36 when you reduce that fraction. And here, when you divide a negative by a negative, you get a positive. And then y plus 4 squared over 16 equals 1. Now this doesn't quite look like an ellipse yet, because remember, there has to be a minus sign. So if we just switch the two orders of this is really y plus 4 squared minus x minus 6 squared over 36, and the 16 is here. And now that's my equation of an ellipse. And that ellipse is vertical. I'm sorry, I don't mean to say ellipse. Hyperbola. That hyperbola is now vertical with a center of 6, negative 4. So with this type of completing the square, you need to do a little manipulating if possible. Alright, jot down any questions that you might have, and don't forget to do problem number 4 for homework. Give it a chance, and we'll go over that in class tomorrow. Okay, have a good night.